This conference will now be recorded.
Okay. Uh, uh, so this is Roshan, guys. Coming to just this is like an introductory session for my course, which I'm coming up from today. Today is the first demo session on the cloud performance engineering DevOps. So a little background about me before we get started. So I have around 14 to 15 years experience in IT. I have worked predominantly in performance engineering field, Java and Python development. And on the cloud side, I'm a multi-cloud professional and a certified architect associate professional, cloud professional, and been involved into automation with various technologies, Java, Python, Terraform, Ansible, PL SQL, self-scripting. I'm currently working as an SRE, principal SRE. So this will be the agenda of our discussion today. So we'll start with a question and we'll understand the software development and deployment evolution, how software was developed and deployed over the period of time. Uh, since we started from the inception, we'll get an understanding of that. And then we'll go over the course details, we'll set the expectations, and if you have any questions, you can ask. Okay, let's start with a question. I need, so during the conversation, I want you to, there is a chat window for you. You can just write your answers there, and if you want to speak, you can unmute. And I want this to be very interactive session, so very introductory. So feel free to unmute and speak, and please answer in the chat. So I want everyone to answer this. So I just want a general opinion from everyone. Do you think that performance engineers or a DevOps engineer or looking at performance testers are expected to know these technologies? Looking at the current market trend that we are into, we are into cloud, we are into DevOps, microservices, and containers. So how many of you agree that a performance engineer, a tester are expected to know this? I need to understand a general perception. Yeah. So I see Nishant is agreeing with me. Prasanna is also agreeing with me. Prem as well. I want others to be on mute. If you're not speaking, please be on mute. I don't want to do it everyone mute from my side. So if you're not speaking, please be on mute, guys. And if you feel free to unmute and speak. Okay, whenever you feel like. I think most of you are agreeing to this. So correctly put. So we are on the same track. So even I, being from the performance background and from the system admin perspective, I know these are very much important skill sets to have looking at the current market trend, be it cloud or be it DevOps or microservices, and where do we hold these microservices containers? And if I want to just stretch that further on the container side, Kubernetes. So these are a very important uh, technology for this current and for the current market trend. So looking at this particular slide, so my course is designed around these four things to be put it upfront. And and here I start look at the software development and deployment evolution. So this is how over the period of time the software has been developed and deployed. If you look at the waterfall, the development process, we started with waterfall way 1980s, and we used to develop monolith applications. Let me just put one layer. So we used to use a monolith applications. We used to make all the applications, and we used to have all the application logic at one place, deployed in one place. That's on the one application server, and all the modules were tightly coupled. So we were developing a monolithic applications. We were waterfall model, and we used to deploy directly on the physical servers. It was such a because that's how we started up. That's how we started up. We never knew that something called virtualization existed back in 1980s. So whatever software that we developed, we directly deployed on the physical servers, and then we there were no kind of a cloud hosting mechanism that time. So whatever we developed the software, we had to create a data center. If you are not financially well off. You cannot afford that time during 1980. You cannot run your application. So this was the scenario back in 1980s. We progressed. Waterfall. We understood there were a lot of issues with waterfall. You guys, everyone know, right? It's not a hidden fact. And we shifted to agile, where we carried out the development in phases. In waterfall, how we did, we completed the development first, and then we started with testing. There were a lot of issues when something very important came up in the testing phase. We could not go back and fix the architecture. It was such a pain, and it was such a drawback to start with. So we understood the problem with waterfall, and what we did, we started to develop the software in various phases. We call these sprints. So step by step, we completed one phase, and then we did proper testing of that phase, and then we started with the second phase of development, and that's how agile developed. And currently, we are also into agile. Agile is not having much of an issue. We'll talk about what DevOps bring to the table. But that's how we developed from waterfall. And from monolith application, we progressed to n-tier application. We started to build three-tier application. We divided into web server, app server, database server. We had divided our architecture, and we started to build a three-tier application. On the physical server side, we made tremendous progress, and we were able to understand that if we do not do virtualization, we are going to waste a lot of resources. The physical deployment of the software on the physical servers was not at all right thing. So what we did, we on top of the physical servers, we installed something called virtualization software, VMware, Oracle. There are a lot of softwares out there for the virtualization, which will help you to virtualize the hardware. So we installed those virtualization software, and then we created VMs, and then we installed our three-tier application, whatever tier we have, separately on these VMs. So it was a very good progress that we made. And there were few organizations who started the hosting as well. It was not that full-fledged, but few people started. But currently, the phase we are in is this phase, where what we are doing, we are making it better from agile. What the agile has few drawbacks, because what used to happen, the developer testing one environment, testers testing another environment. There are a lot of configuration issues, a lot of challenges in having a proper communication between the developers and the operations guys. So what we did in DevOps, we automated the complete process. Our main intention is when the code is ready, right, from the developer end, I want to deploy that code as soon as possible in the production without compromising on the quality testing, be it either functional testing or automation testing or performance testing or security testing or penetration testing. I don't want to compromise in any of these quality testing, quality validations, and I want to deploy, but I want to deploy my code as early as possible, as soon as possible. So how can we do that? We need to automate this process. Once the developer completes its activity of developing whatever code it has or fixing some bug, whatever any code changes, anything happen in the code, I want the code to be auto deployed, auto build, auto deployed, and then proper testing. And once all my all criteria is met, I want to deploy that code to the production as soon as possible. That what DevOps bring to the table. We are trying to automate everything. And that's the phase we are in. So that's how software has been developed and deployed over the period of time. We are in this phase. Now we had three-tier application. Still, it's a monolith application. I'm not denying it's something different, but we just divided into web server, app server, and database server. But again, the app server is monolith still. All my code resides on the same application server. And that has a lot of challenges again. So what we did, we divided that modules. Let's say my app server business logic has 10 modules. It could be anything, different modules of my bigger application. So what we did, we divided those modules into microservices. Smartly we divided. And what it offers a tremendous advantage, because what used to happen, what happens in monolith application, that even for the smallest of the region, my entire application could go down, which is not a good thing, right? That's why it's better to divide your business logic into separate independent entity, so that one of the module is not going to impact other. Let's say if I have a Swiggy application, or Uber app, whatever app I have, these are all based into microservices. What if I say you that if my notification tab is not working in those applications, you cannot book a cab or order your food? It's ridiculous, right? Notification tab is independent. What that particular functionality is to do with my main thing, right? Main functionality of my application, and that is only possible today. That even for the smallest, like if my one microservices, one of the module is not working, still my all the other important main microservices are working. So still my I'm functional. I'm not down. My application is not down. There are a lot of advantages microservices bring to the table. And then what we did from the virtualization servers, we divided the VMs into multiple containers. So the idea has always been to efficiently utilize the resource. When we progress from physical servers to virtual servers, VMs, the goal was the same. We wanted to efficiently utilize the resource. If it's proper utilization of the resource, we don't want to waste the resource. I don't want the resource to be underutilized. For that sake, I was using virtual servers. Containerization, this phase is called containerization. This phase is called virtualization. This phase is called containerization. Containerization offers that in a greater depth. What it happens, it further breaks down the VM, one VM, into multiple containers. And I deploy my containers there. For example, to put it in a very layman term, if I have a three-tier application and I was using three VMs, let's say one VM for the web server, one VM for the app server, and one VM for the database server, let's say. With this containerization technology, I can have three containers in one VM itself. I can have one container for the web server, I can have another container for the app server, and I can have another container as the database server. So what I'm doing, I'm making sure that this particular VM is efficiently utilized. And then only I'm going to the second VM. If I need to scale, if I need more resource, if I need more compute, if I need more hardware resource, then only I'm going to use another resource, another VM. So that's the containerization phase. And these microservices are deployed on these containers. So that's the phase we are in. And how do we create containers? We need to install Docker or any sort of container engine on the VM. So from this physical server, we had to deploy one virtualization software, right, to create VMs. Now from this VM, if I need to create in this VM, if I need to create multiple containers, I need to install something called container engine, like Docker, okay, and then I can create containers. There are other players also in the market. We have Docker, we have Containerd, we have Rocket. There are so many, but Docker seems to be the most popular one here, and we are into the containerization stage. And moving to the cloud, now we are into the full-fledged. There are so many players out there in the market who are ready to offer cloud services. If you do not have the hardware, if you do not have the enough capital to build your data center, no worries. You can rent the servers from this cloud service provider. I can rent servers in AWS. I can rent servers in Azure. I can rent servers in GCP. There are so many cloud service providers. Alibaba is there. You have IBM is there. Oracle is there. So many cloud service providers have come. And I don't need to set up a data center, because maintaining a data center, setting up a data center is a very costly affair, right? So this is what's going on currently, and this is where we are, and it's going on in the full pace, and we are in this phase. And the course which I'm going to introduce you is about these four things. It's completely into these four things, and it's configured for the performance testers, engineers, DevOps engineers, anyone who is looking into to learn these technologies in general. This particular course is designed for that. Do we have any questions here? I will just wait. I'll take a pause for a minute. I want to think. And do you have any questions on this particular slide? Feel free. Okay, I thought someone had some question. Okay, so looks good. I take the silence that we are all good. Perfect. Moving to this course. Okay, so this particular course is divided into, as I showed you, 4-5 stages. Okay, so we are discussing about cloud computing, and we have taken AWS. So whatever we need for the knowledge that from the very basics, from the very scratch of the things, when you have started with the cloud for the first time, don't know anything what is cloud, I'm going to take you from there to a very significant level, which can prove very important for your growth in the IT in your career. So I'm going to talk about cloud computing. I'm going to take care of AWS. I cannot take up multiple cloud like Azure and GCP all together because it will not be possible for me to complete other things. But having learned one particular cloud service provider, it's very easy to learn any other cloud service provider. It's the same setup because all cloud service providers out there in the market, be it AWS, Azure, or GCP, they're all competitors. If one guy creates one service today, the other guy in 2 weeks creates the same service, and we have just the naming difference. That I will cover. That we name this in AWS, but we name like this in Azure and GCP. So in that way, we'll cover those other cloud service providers as well. But I'll focus on the AWS because AWS has the largest market share. 40% of the complete market share is captured by AWS, and the reason is they have started quite early. They were introduced in 2007, 2008. They came up quite early in the market, and they have the largest. They have the most of the services widely used. Everyone prefers using AWS. So we'll cover that. All these things that we're talking about, your Docker, your containers, your Kubernetes, all those things need a basics of Linux command line because the microservices and the containers, Kubernetes, it's all possible only on the Linux operating system, Linux VM. It's not containers, Kubernetes is not there for the Windows operating system, okay? Because Windows operating system is quite heavy. It's not there on the container technology is not there. So everything is going to deployed on the Linux operating system. So considering that, we're going to cover the Linux command line from very basics. I'm going to talk about LS from how do you spin up an instance to issuing the command like ls and date and cal. From very basics, I'm going to take you, and I'm going to talk about self-scripting. I'm going to talk about software application architectures that we have monolith and what is microservices in detail. I'm going to talk about where do we host these microservices, what is container engine, and where do we host these microservices. So the answer is containers, but how do we create containers? We'll talk about that. We will be installing container engine Docker in our VM. I'm going to show that this is how we create containers and this is how we host microservices. If you have a lot of containers out there, you need some orchestration. Like you are in the cloud, right? You want to auto scale things. Earlier, what used to happen? We used to maintain the hardware in production. Let's say if there is 500 user expectation in production maximum, so we used to configure my production with the maximum possible configuration all the time, 24/7 throughout the year for 500 users. It's not like that 500 users are always accessing your application. No, it's only during the peak time. Let's say during 10 to 2 or 10 to 1, 10 a.m. to 1 p.m. That's it. Only during this time you have the maximum user accessing your application. Rest of the time you don't have that much of user. But the problem when we were not in cloud, the problem was we have to maintain the hardware, same hardware in production all the time. But we are into cloud phase. Cloud is elastic. We have auto scaling. And what we do, we can scale things automatically. If I need the service, if I need more compute, if I need more resources, then I will have it. I will have some criteria on my CPU memory, and I would make sure that I'm not using the resource without any need. Whenever I need, I'm going to ask, request AWS to provision me resources, and I'm going to be charged only for that time. But for the time I'm using that additional hardware, I'm going to be billed accordingly. And we need orchestration engine. So there are a lot of other activities apart from auto scaling. You need auto deployment, and there's so many things out there. We will be learning Kubernetes. Kubernetes is from Google, and Google has been using Kubernetes for more than a decade now. So you can understand how Google has been managing their workload that well. Because everyone, I don't know anyone maybe in IT who doesn't do Google, right? Everyone Google, right? And that's how they have been giving you such a good performance with that much of workload, because they have been using Kubernetes, and that's why all the other industries have inclined towards Kubernetes, and they are relying when they are developing their application, microservices, they're hosting on the Kubernetes. And that's how we will learn into Kubernetes. And important DevOps. We'll understand how DevOps work, where, how performance engineers, performance testers fit in DevOps, what is the performance engineering role in DevOps. We'll look into that, and how do we do performance testing in CI/CD pipeline. That's the course structure that we're gonna follow, and this course is designed on this. So everything that we have discussed in the last slide, this is what you get, and from very basics. That's the USP of this particular course. Coming to the elaborate discussion on each of the topics. On the cloud computing, I have a list of topics. You can see if things are new to you, you may not relate that, but whatever you see here in this slide, I'm going to cover everything. For the cloud computing, we mostly 15 days we cover. So this is going to be a very extensive session, so around 40 hours. And we're going to meet every day on the weekdays, 9 p.m. to 10 p.m. around this time, same time, IST, every weekday. And we're going to meet for 8 weeks, 1 hour every day. And it's 40 hours, this particular course, because you can understand what the things we are covering here. We're not just covering the cloud or Kubernetes, we are covering everything altogether. So it's going to take some time. On the cloud computing, we're going to cover these things. I don't want to go over each and every topic right now. It may be overwhelming for most of you guys. So just understand, take my words, it's going to be from very scratch, from what is cloud computing and how it is different from on-prem and different service models that we have, infrastructure service, platform as service, software service. We're going to talk from very basics, and everyone is going to have an AWS account created. I'm going to make sure that everyone has to practice it. That's the and I'm going to check everyone that everyone will have this account, the one which I'm about to show you. So everyone will have this account, and we're going to log in here, and I'm going to practice everything here. So this is the AWS console, and this is how we work in cloud. So AWS has provided us this console, self-service, on-demand console. If you need servers, we can get it. If you need database servers, we can get it. If you need Kubernetes, we can get it. They would charge, but that's how it is. Obviously, because I'm not going to set up a data center, right? I'm going to simply use the servers. They're going to obviously charge for the servers, right? That's why they have made it public, right? So that's about AWS. For the Linux, okay, I'm seeing this question. Nilesh, duration of total course is 40 hours. 40 hours is 8 weeks. We're gonna meet for 8 weeks, and we're gonna we're gonna take this on the weekday, 1 hour every day. Because I don't think so. More than 1 hour is gonna make any sense because I'm gonna give a lot of information and you need to digest as well and practice as well. So 1 hour, I feel it's the quite optimal way to go ahead. Dave had asked me a question. Any prerequisites what is required to get best of this course? Nothing, Dave. So that's the beauty about it. I have made it in such a way that you don't need any prerequisite. Yeah, being from IT is a very important thing. I cannot tell that if you're not from IT, it's going to be difficult because I'm going to talk in IT terms, right? I'm going to talk. I'm going to assume that you know waterfall, agile. Then I'm going to talk about this thing, right? DevOps. I cannot teach you DevOps if you do not know waterfall and agile. So I'm going to the prerequisite that you should be from IT. That would be one of the things. But I don't expect you to know any of these things. You to understand what is virtualization because you must be working in VMs. Then we're going to talk about containers. I'm going to expect there is something called 3-tier application. So basics of IT. I just want the participants to have basics of IT, which everyone should have. That I expect, and I don't expect participants to have knowledge on these things at all because I'm going to cover these things from very basics.
One more question, Roshan.
Yeah, please.
Yeah. So regarding the Docker and containerization, I have got zero knowledge about it. I am from IT industry also, but I have got basics about AWS, but don't know anything about Docker and containerization. So and
That's
Kubernetes.
perfectly fine, Dave. That's
Yeah,
perfectly fine. That's why this course is okay. That's why because I know most of us would not have this knowledge. You luckily have some AWS knowledge, but I know most of the people would not have been introduced to the cloud world because they would be working in some on-prem infrastructure. Even if they are working in cloud, they don't know where to start and where to go. They would be using some VMs. So I'm aware of these things, and that's why this course. And I know the pain point, and that's why we are pitching in to help you guys.
And one more small doubt, probably a stupid one, but still just wanted to clarify that this Docker and Kubernetes, you'll be coming from a perspective of a performance engineer or a regular understanding that is required for everybody to kind of know about it. I mean, like,
See,
will you be?
Okay, I understood. See, to be of any help for a performance engineer or automation engineer or DevOps engineer, first of all, you should know what it is. Performance, first of all, you should know how it is deployed, where to look for the logs, how to look for the monitoring part. Those are the very key criteria for a performance engineer, right? Once we understand what it is, how it is deployed, and where to monitor things, and what to monitor, how to monitor, where, if there's any issue, where to go. So that's what the basic troubleshooting I'll be starting up. So because why I'm speaking about the performance engineer, yes, because it's kind of streamlined, it kind of this particular what I would say for a performance engineer for sure, but not just performance engineers. Anyone who is having not some performance engineering background, this course is going to help them. If someone is looking for the DevOps aspirations to be a DevOps or looking for a support where they need to work on Kubernetes or any automation, it's going to help everyone because I'm going to talk about some very basics because I assume that you don't know anything about Kubernetes or Docker. So I'm going to start from very basics and then later I'm going to tell you about where to look for the logs, what to monitor, how to look for how to troubleshoot because the performance engineering part is going to be the same because at the end of the day, Kubernetes, you will have pods, means containers, and the container would be running on Java. So I'm not going to talk about again the performance engineering concept, how to take heap dump and thread dump. That's the secondary, but I'm not going to talk about those things again. But whatever is specific to the Kubernetes, the engineering part of the Kubernetes helping for the performance tester or engineers, I'm going to cover that. So I hope I answered your question. Right?
Are you covering like OpenShift as a container for the Kubernetes?
See, in Kubernetes, there are a lot of things. Okay. You have OpenShift, you have, if you talk about AWS, you have EKS. If you talk about Azure, you have AKS, Azure Kubernetes Service. If you have Google, you have GKE. I'm going to talk about in general specific terms, first of all, not to OpenShift. I'm going to talk about a general introduction to Kubernetes, and then I'm going to take my discussion to EKS, which is the AWS offering of Kubernetes. So once you have a general idea about the Kubernetes, you can take up any Kubernetes out there, AKS or GKE. But this particular thing is very much focused about AWS. So we're gonna take care EKS. And the general introduction, general thing, how do we work on Kubernetes, and then it's EKS, Elastic Kubernetes Service. Because if we start talking about Kubernetes world only, Kubernetes itself can take 40 hours of the course if we talk about complete Kubernetes thing. All the cloud service provider has a different way of implementing. AWS calls it EKS, Azure calls it AKS, Google Cloud calls it GKE. Then you have OpenShift, and there's so many other things you have it, right? So I'm gonna focus on the general introduction of Kubernetes, and then we're gonna take you to the EKS because we are very much specific to the AWS. Okay, I see one more question on Devanshu Goyal. I'm more aligned to Azure Cloud and AKS due to work coming in a few months for me. Okay, Devanshu. So what I can tell you, whatever I'm gonna discuss here, it's gonna be very much relevant to AWS. But having said this, if you are new to everything Azure and AKS, this course is gonna help you because once you learn one cloud service provider, it's very easy to learn others, right? If you are from any background, automation background, so you know that, or a performance background, if you know one tool, like a LoadRunner tool, it's very easy for you to pick up any other tool. Let's say if you have worked on RPT, Rational Performance Tester, you can work on OATS as well. If you worked on LoadRunner, like their concept was same, right? You just need to know about it. So that's what I can tell you, Devanshu, that this course is going to be very much relevant to AWS, but I'm going to talk about Azure as well, that what services maps to what. Only the name changes, but the core functionality remains the same. I'm going to show you one thing, very important. If you guys have no idea, see, this is the AWS console, right? And for if you need the servers, you go to EC2 instance. You go to EC2. EC2 is a service, okay? You go to EC2 and you get some instances, okay? Any servers of your configuration. Same thing for Azure, you have it, okay? So what you do in Azure, you call it virtual machines. The name changes, the UI changes. I'm not denying that, but the core functionality is gonna be the same. There, AWS guys call it EC2, but here these guys call it virtual machines. So I'm gonna come here and I'm gonna do the same thing. Whatever I'm gonna do there, I'm gonna configure my VMs in the same way. Only the name changes, right? Virtual machines. And if I talk about GKE, they call it compute. I have GCP as well. These guys call it compute engine. For the same thing, three name. I just gave you one example. These guys calls it compute engine. I'm going to show you that. This is GCP, right? These guys call it compute engine. So what you do, if you need a VM, you go to compute engine, and then you go to VMs, and then you get your VM as per your requirement. That's how you do it. So it's the same thing, same world, different UI, obviously, three different companies, but the services they have is very much is almost same. Only the name changes. So that's why I'm going to focus on AWS here, and others you can pick it up. And that's how I have learned things. I started with one cloud service provider, and then I have learned others on my own. Will this course be still helpful for me? Yes, Devanshu. As I think I have answered your question, right? So you can take a decision. I have explained my part. You can take a decision.
Yes, Roshan, that answered my question. Just one more thing. In the end of the course, like right now, all the things are new for us, and I think everyone, these Dockers and Kubernetes, we have heard about the names only, but don't know what's the functionality. So in the end, as you talk about like for Google, Azure, and AWS, do we have the comparison chart like EC2 in AWS and Azure VMs in AKS like
If
that?
you're
Can
looking for that information right now, I can give you.
oh, that will be
I'm
great.
very much open. I'm very much open to shared knowledge. Okay, I can give you this particular link. Compare
Mhm.
cloud.in. Just take this link, and your problem is solved. In AWS, I'm not going to talk to you just about AWS, Azure, and GCP. I'm going to talk about 6 different cloud service providers. So whatever peak you can have it. AWS calls it EC2, Azure calls it virtual machine, GCP calls it compute. IBM Cloud calls it these names. Oracle Cloud calls by this name. Alibaba it calls it ECS. Huawei Cloud. There are so many players out there. I cannot know about everything. So there is a very exhaustive list. If you want to just have a comparison, have this link. Compare cloud.in. Right? So yeah.
Awesome.
I'm going to talk about these things. I'm going to explain these things in very much detail, and I'm going to you're going to understand. Okay, I just introduce you. I'm going to talk about it in detail. I'm going to show you a few things. You'll be comfortable. Okay. Okay. I hope I answered the question, Devansu.
Yes, Roshan, pretty much. Yep. Thank you.
Perfect. Okay. So this is about the cloud computing. I started. If you guys do not know anything on Linux, I'm going to come to the questions later. Okay. I just have 1 hour, so I need to plan it. So, okay. So if you're coming to the Linux command line, it's going to be from very basics. Okay. If you do not know anything about Linux, that will still do. Okay. Because every time what I do, I ask my class, I just ping them and I check, rate yourself from 1 to 10 level. And I get most of the answers as 1. They don't rate themselves very well. In Linux, I understand because they have not been guided properly. Linux, they are very much comfortable in Windows, but coming to the Linux, they're not comfortable with the command line. Once you know it, you're gonna just think why I was not that comfortable. It's so simple. You just need to know ABCD of that, right? It's just knowing something how to get things around. So I'm going to talk about some very basics. I'm going to also show you some shell scripting as how to get started on the Linux command line. Coming to the software application architectures, I'm going to again talk about what is a monolith, what's microservices, advantages, disadvantages. You're going to be comfortable around these things. Containers, you're gonna just because that's the basic thing to get started. Because this is where we host microservices, and we need a container engine to create containers, and we're gonna talk about Docker as the container engine, and we're gonna look for a lot of operations. How do we work? So Docker compose, Docker uh, file, how do we create image, things like that. I'm going to talk about that. And everything from very basics. I just want you to understand this. But I know the pain, what it takes if someone doesn't know anything, how blank they feel. Considering those aspirant only, this course is for them. Because if someone knows it, they can just learn on their own. But to get started is the key. So this is where I'm coming in. We're going to talk about performance engineering in DevOps. What was the situation before DevOps? How DevOps? What is the intention of DevOps? Where performance engineering fits in DevOps? What is the roles, responsibility of a performance engineer? What all we can perform? Things like that. We're going to talk about it. We're going to talk about Kubernetes. Everyone is asking about Kubernetes, right? You must be filling in your interview. Everyone expects you to know Kubernetes. I understand that. We're going to start from very basics. We're going to talk about. I'm not. I don't want to go over these things. I don't want you to feel I'm going to teach a lot of things. No, it's going to be very simple. I'm going to take it step by step. I'm just highlighted these topics for you to just have a look at it. HPA, very important thing, right? For the performance engineering guy, you want things to auto scale. if more users are coming and hitting your application, you want things to get auto scaled, right? And that's what everyone does it, right? You cannot maintain a fixed number of hardware in production. That's going to cost you a lot. If you do not have load in production, or why do you need service then? So auto scaling is the key. I'm going to talk about horizontal call auto scaler, things like that. A lot of components. Kubernetes is very, very complex topic. You very important to get started in a very systematic way. I know that. So we're going to take it from there. We're going to understand continuous performance testing in DevOps. What is the performance engineer tester role in DevOps? We're going to talk about that. And these are all, we're going to execute the pipeline. We're going to create the pipeline, and we're going to do the automatic triggering of the pipeline. And all these activities, once the developer pushes this code to their GitHub, it's a source code repository, we call it. Once the developer pushes the code to the GitHub, everything should get automatically executed. You're building the website, executing the Jmeter script, and once it's processed, you want the code to be deployed in production. You're going to understand how things go here, so that you can contribute in your organization with your job, performance job that you're going to create using any performance testing tool. So we're going to take Jmeter and we're going to understand that. How to do email notifications, automatic email notification. Once this job is successful, you want yourself to get notified. And if this job fails, you also want to get notified so that you can take proper action. We're going to talk about Jenkins as a CI tool. So that's in the entire thing about the course. I don't want to spend some more time there. You can be very much comfortable. What will I learn by the end of this course? You're going to learn everything out here. You're going to learn more than 20 to 25 AWS services, Linux from scratch, Docker from scratch, containers from scratch, Kubernetes from scratch, DevOps from scratch, everything from scratch. I don't expect you to know anything. You just be from IT, that will help you. Yeah. For more details, you can log into this website. You can find the details here about the course content. You can go over my demos from the last batch. It always takes 2 months for me. Okay, 8 weeks is a 2 month, right? So it always takes 2 months for me. So this last batch, October, so coming up in January. So you can go over my demos, initial demos. You can go over my feedback that I have got it. The real feedback. You can just go over what will I like by the end of this course, all my syllabus. This is going to take 40 hours, guys. This is a very exhaustive course that I created. So it takes time. Every good things take time. So you're gonna have this link with you handy. I'm gonna give you this link. You can have a look. What is this? Let me just. Yeah, you can refer this link and can get some more information. I'm gonna switch my discussion to the questions. Okay, feel free, guys, to ask me questions. We have some time. Are you gonna run load test using any tool? See, I'm gonna demonstrate things using Jmeter. I'm gonna do that. So as part of the continuous performance testing in DevOps at DM, I'm gonna do that. Will we explore any APM monitoring activities on microservices and Docker, continuous both application level, infra level? See, again, those monitoring, I'm going to talk about where do we monitor the microservices, containers, the pods, those things. And your APM level information, that again, if you go inside how your microservice is based on Java, if it's run Java, again, the same thing, heap dump, thread dump. You need to look into those things, GC log analysis, things like that. That I'm not going to cover. That's a separate thing. I'm going to focus mostly on the Kubernetes part. So what is the performance related activities, troubleshooting, related to the containers and Kubernetes. I'm focused there. How do you monitor Kubernetes cluster? How do you monitor pods? I'm going to focus there. How do you auto scale in Kubernetes? I'm going to focus on there. I'm not going to focus on the APM tool and the process level information, why this Java process is having this issue. I'm not going to talk about that. That course is completely different. That comes under the Java performance engineering, Vijay, right? So I'm not going to
Yeah.
focus on that.
No, I just want to know, now it is only the agent, but in the microservice and Docker, we are just getting the from the network folder, we are updating the microservices. But if you want to install it, or if you want to make as a package, we will be able to do that. That's the query.
See, I'm gonna tell you how to use YAML file to deploy your microservices, containers, your pods, your, if you know about microservices, your services, your load balancer services, your node port services. I'm gonna write YAML file, demonstrate YAML file. I'm gonna write kubectl command to deploy things, Kubernetes objects. I'm gonna show you how to deploy things, how to deploy your application. And you are not going to just, because you need images for that, and images you're going to get from your developer, right? From the development team you're going to get those images. But I'm going to show you how to make those images and how to deploy things on the server, right? In the Kubernetes cluster. I'm going to show you that using YAML file, kubectl
Okay.
yeah. And how to monitor those cluster, your pods, things like that.
Just means idea about how to monitor microservices, because in server level we know that we copy the jar file there, but in microservice it is completely different.
Correct, because the way the architecture is completely different. Once you know, so the first thing that we do is to make you understand the Kubernetes architecture, how Kubernetes is architected. That's the first thing we talk about, the master slave configuration. If you look at this particular slide, you will not get much information. This is something called master node, and this is something called cluster. In the cluster, you have multiple worker nodes, EC2 instances, and there you deploy these pods. These pods have the containers, and these containers will have your real application. So I'm going to talk to you about how do you create this cluster, how do you deploy these containers, pods, and how do you monitor it. I'm going to talk about those things. You're going to be comfortable.
Okay.
That's what I can tell you.
Yes, that's what I required actually.
Right. So that is what we are doing. Yeah. Okay. Will you cover analysis part as P analysis is the main part? What do you expect, DM? Can you be elaborate? I don't understand your question. I have answered you, I think. What's your question, DM? I see your name as DM, so please feel free to speak. So as I mentioned, right, I'll be talking about the analysis on the Kubernetes side, the pods, the container side. I'm not going to drill down on the what is deployed, Java application. Again, I'm not going to talk about the Oracle, if it's Oracle database deployed. Not going to talk about AWR report. I'm going to talk about the container level information. How do you monitor, where to check the logs, container logs, and things like that. I'm not going, yeah, CPU memory, yes, I'm going to show you that. Right, I'm going to show you that. Okay. Yeah. Any more questions, guys?
Kumar, from when the classes are starting, real classes?
Right, tomorrow, 9 p.m.
Tomorrow 9 p.m.
Yeah.
So I have already opted for Dynatrace, so it's going on. So now for this, I'm thinking.
Okay.
Can we get the recording as well?
Right, you will get. That's how it is. For this demo, you are getting the recording. Obviously, for the classes, you will get the recording. Right? You will get lifetime recording. No one remembers everything from the session. That's when the things are new, right? So we provide recordings of the daily, whatever the sessions that we will have, you will have the recordings of that. So,
Kumar, how much it will help as because I have started APM just 1 year back. So on the legacy systems, not on the Docker or microservices, will it help me to grow or help on the APM side? This course.
again, when you say APM side, what do you mean? You mean
Means that I
AppDynamics?
just need before going to the monitoring part, I need to know the backend infrastructure. How we monitor the servers, I know that idea, but in the microservices, that is completely new to me. And even the DevOps now the complete automation is that they say that we want to integrate your CI/CD. You monitor the auto scaling. You check the health of the microservices pod level and show them the topology view where exactly it is having issue. Means infra
Right,
level as per the course.
exactly. So this course is, so we'll talk about the infra level only, right? I'm not
Oh,
going to deep dive on the process level, like Java process level or database layer, database process level. I'm not going. I'm talking about the infrastructure level only, or auto scaling, the container logs, the pod logs. I'm talking about those things only. Auto
okay.
scaling, load balancer. I'm going to talk about those things only. Yeah.
And what about the service mesh? Is there any service mesh will be there included in this
Yeah, see
service mesh?
again, service mesh is quite a very vast thing. We're gonna start from very basics, okay? And we're
Okay,
gonna
okay,
we're gonna cover things. We're gonna cover things. So service mesh comes very later. Right?
okay,
So we're gonna start from very basics. So
okay, okay,
then we will take it. We'll ramp it. Yeah.
okay.
Okay. Yeah. So guys, so you can contact if you want to register, get registered. Feel free to contact this number. This number of Mr. Kumar, and you can find his number here, Kumar Gupta. You can find his number here on this particular link. You can contact him to the enrollment process.
Hi Roshan, I have a small doubt.
Sure, Pradeep.
I'm
Go ahead.
already
Yeah.
I'm already working on a product-based company. If in case if I got any doubts regarding on our course related to our course, can I ask you regarding on those? Like if I got stuck on some other work like uh, instances creation or some EKS instance or CI/CD.
I'm gonna cover that. I'm gonna already cover those things. So what
Yeah.
I will ask you to wait for that particular topic to cover. Still, you have
Okay.
doubts. You're very much welcome to ask me questions. But
Okay.
I'm sure that
Okay.
once I cover that particular topic, you will not have any more questions.
Okay. Sure. Thank you.
Sure.
Thank you. That's it.
So I would request everyone to go over this link and yeah, and get the details. And you can ping me in WhatsApp. I'm there in the group where you have come join. You can reach out to Mr. Kumar for more questions. And if you want to directly talk to me, yeah, he can provide my number to you. So feel free to reach out to him if you're looking to enroll on this course.
So,
Perfect.
so
I
when
think, yeah,
the session gonna start?
from tomorrow. It has already started. Today is the demo. We're gonna start from tomorrow. So the day one.
Tomorrow
Day one is tomorrow.
session starts
I'm gonna
on.
talk about cloud computing. Yeah, Mohammed. Any more questions?
No, I'm just excited about the syllabus. Thank you. I'm
Perfect.
excited.
Perfect. So okay, guys. If we do not have anything, we can close this session. Yeah. You have a great day. If you're working in your daytime, and have a great night. Good night. It's quite late for you. for you. Okay, guys. Thank you everyone for joining. We'll see you tomorrow.
Thank you.